Hey there, guys. So I'm going to try to give you the answers to homework number 9. And first I'm just going to read through the answers quickly so you can check your paper. And then you can slide through the video and I will explain each problem and you can just slide through and pick the problems that you want explanations for. Okay? So number 1, A should be 1/4, B should be 1, C should be 1 over 25, and D should be 1 over x squared. Number 2, A should be x equals 2, and B should be x equals 53. For number 3, A, yes, it's a function because each input has exactly one output, right? It passes the vertical line test. B, yes, same reason, each input has exactly one output. And C, no, it's not because, for instance, the input 0 has two outputs, one at maybe negative 0.5 and one at 2.5. For number 4, A, the domain is all real numbers, and the range is 1 less than or equal to y less than or equal to 3. For B, the domain is all real numbers, and the range is y is greater than or equal to 0. And for C, the domain is x is greater than or equal to negative 2, and the range is all real numbers. Number 5, in scientific notation, it would be 1.6 times 10 to the 8th. For B, it would be 5.8413 times 10 to the 10th. Love problem number 6. I really wish I was there to see who got it. The area should be 68 square inches for the shaded region. And number 7, the exponent problems. A is 56 x squared y to the 4th. B is 27 m to the 6th, p to the 9th. C is 4x squared y to the 3rd. D is 3 over x squared. E is 4 p n to the 2nd. And G is 3m over 2n to the 3rd. All right, let me go through an explanation on the board of each problem here. And you can just slide through and pick the ones that you want. All right? Here we go. So, what we learned is that the rule when you have a negative exponent is take, still do that even on video, right? Take the reciprocal of the base, and that turns the exponent positive, making it just 1 over 4 to the first, or just 1 over 4. Letter B, anything to the 0 power equals 1, so this is 1. Again, for letter C, I need to take the reciprocal of the base. That turns the exponent positive. And then when you have an easy number like 5 to the 2nd power, you should go ahead and do the exponent. And last up, letter D, take the reciprocal of x, which is 1 over x, and that turns the exponent positive. Okay, number 2. Number 2, I want to, I know the output is negative 1, so I'm putting negative 1 in for f of x. And this would be negative 1 equals 3x minus 7. So I put negative 1 in for the output, and now I solve for x, the input. And I would add 7 to both sides, giving me 6 equals 3x. And I would divide both sides by 3 and get x equals 2. Letter B, a little bit trickier one, right? This time I know the output is 10. So I'm putting 10 in for the output, and I'm going to solve for the input. Well, the first thing I want to do is get rid of this square root sign. So I do the opposite of square rooting something. I square it. I square both sides. When you square a square root, it just cancels out the square root sign. And when you square 10, you get 100. And now it's simple, right? Just get the x by itself. So you would add 6 to both sides, giving you 106 equals 2x, and you would divide both sides by 2 and get x equals 53. And you could plug that back in and check and make sure it works. I think you'll find it does. Next up, number 3. All right, so the best way to do a graph is the vertical line test. All right, when you run your pencil across the graph, which I know doesn't translate very well on video, there are no places where that graph touches the same vertical line twice. So it passes the vertical line test, which means it is a function. And it's a function because each input has exactly one output. That is always the reason why something is a function, because each input has exactly one output. Same thing for letter B. Again, I don't know how well you see that on video, but when I run a vertical line across the graph, it never crosses the vertical line in more than one place. So it is a function, and it's the same reason as that one. Each input has exactly one output. But letter C fails the vertical line test. So this vertical line right here, which happens to be the y-axis, there are 2 points on the same vertical line, which means the input 0, it's not a function, because the input 0 has 2 outputs. And they are like right there, 2.5, and maybe like right there, negative 0.5. But the bottom line is it fails the vertical line test. There are 2 outputs for the same input, not a function. Which brings us to number 4. I now want the domain and the range. Well, it's going to be harder to do on video, I feel like. Okay, so graph A stretches left and right the whole way across the graph. It would keep going to the right, it would keep going to the left, which means the domain is all real numbers. Right? Eventually it hits every negative x value to the left and every positive x value to the right. However, as far as the range goes, this is like the highest y value, and this is like the lowest y value. So all the y values are between those 2 spots, which I believe is at 3 and 1. So the range is all going to be between 1 and 3. Y's are greater than or equal to 1, but less than or equal to 3. All right? Letter B, the domain. Well, again, this arrow keeps going this way forever. And this arrow means it keeps going to the left forever. So just like the first graph, this one stretches from left to right forever, meaning the domain is all real numbers. However, this one has a lowest y value. At these 2 points is the lowest y value, which means the range is all bigger than those 2 values, or all the y values are greater than or equal to 0, being the range. And that brings us to this last graph. All right, the last graph, this time, because of these arrows, this graph stretches to the right forever. But it only goes to the left to right here. The lowest possible x value on this graph is right here at x equals -2. So the domain, I kind of blocked my domain there, the domain would be x must be greater than or equal to -2. There's no x values on this graph lower than -2. However, the range, well, this keeps getting higher and higher, and it keeps getting lower and lower. So in this case, the graph goes up and down infinitely, which means the range could be anything, or as we call it, all real numbers. That is a terrible all real. I get it. But it's all real numbers. We keep going. Number 5. All right, so the key to writing the number in scientific notation is taking the decimal point, which in a whole number is at the end of the number, and moving it until you have a number that is between 1 and 10. So I move the decimal point all the way until it's between the 1 and the 6. And I multiply that times 10 to an exponent. And the exponent is how many spots you move the decimal. It moved 1, 2, 3, 4, 5, 6, 7, 8 spots. It'd be times 10 to the 8th. Same thing over here. The decimal's at the end of the number, and it needs to move until it's between the 5 and the 8. So this number is going to be 5.8413. Not a very good one. That's my number that's between 1 and 10. Now, how many spots did I move the decimal? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spots. It's times 10 to the 10th. And finally, we get to the area problem. Probably my favorite problem on here. All right, so there's two things you need to remember. The area of a rectangle is equal to length times width. The area of a triangle is 1/2 times the base times the height. We need to figure out the area first of the rectangle. All right, so the whole rectangle has an area of 17 times 8. That is 80 and 56, which is 136. That's the area of the whole rectangle. Now what I'm going to do is I'm going to figure out the area of this white triangle, and I'm going to subtract the white triangle from the area of the whole rectangle, and I will be left with the shaded region. So this time I need to do 1/2 times base times height. So it's 1/2. This side would be the base, which is 8. And the height of this, perpendicular to the base, the height is 17. So it's 1/2 times 8 times 17, which I believe is 68. So I'm simply subtracting these two numbers. The whole rectangle, 136, minus the triangle, 68, and that gives me 68. And since these things are marked in inches, I don't know if you know, but those two little lines mean inches, then the area would be in square inches. 68 square inches would be the area of the shaded region. And that brings us to the exponent problems. Here we go. I would multiply the 7 and the 8. Do you want me to expand it out? I'll expand it out. 7x, x, y times 8, y, y, y. I'd rearrange it. And then 56 x squared y to the 4th. Or the easier way, of course, would be multiply the 7 and the 8. The x squared gets brought down, and the y's get added together. Letter B. All right, the best way to do letter B would be to know the rule. The rule is that 3 gets applied to each thing. You have 3 to the 3rd, n squared to the 3rd, p to the 3rd to the 3rd. And then you have to know the rule we went over, which is when you have an exponent raised to another exponent, you multiply them together. 3 to the 3rd power would be 3 times 3 times 3, 27. But when I have an exponent raised to an exponent, I multiply them. That'd be m to the 6th, and this would be p to the 9th. And that's your answer. Letter C. So if I was going to write out letter C, well, let's just do subtraction. This would be 8 over 2, x to the 3rd over x, y to the 5th over y to the 2nd. Okay, this guy needs reduced. 8 over 2 is 4 over 1, or 4. Here I'm going to subtract the exponents. That would be x to the 3 minus 1, which is x squared. And here I'm going to subtract the exponents. That would be y to the 5 minus 2, which is y to the 3rd. And that's my final answer. All right, this is a tricky one. People tend to think that that exponent is on the 3, but it's not on the 3. It's only on the x. Think of this as 3 times x to the negative 2nd. Well, we all know how to take care of that, hopefully. You need to take the reciprocal of the x, which is 1 over x, and you get 3 times 1 over x to the 2nd. And then when you multiply those together, maybe you make the 3 into a fraction. 3 times 1 is 3. 1 times x to the 2nd is x to the 2nd. And that's your final answer. All right, this one's even trickier. So I've got 4p divided by n to the negative 2nd. Remember, that is 4p over 1 over n to the positive 2nd. So I took this thing and I took its reciprocal. Now I'm going to use a little keep change flip, and I'm going to divide these fractions. I'm going to keep the numerator, 4p. I'm going to change it to multiplication, and I'm going to flip the denominator and make it n squared over 1. And now when I multiply, I would multiply the tops and get 4p n squared, and I would multiply the bottoms and just get 1, so it's 4p n squared. And last up, let me see if I can go down a little bit, give myself some room here. Okay, so again, I'm just going to subtract the exponents, but let me make it obvious what I'm doing. So let's write the variables out separately. All right, the 6 over 4, you need to reduce it. 6 over 4 reduces to 3 over 2. Here you have m to the 3 minus 2, which is m to the 1st. And here you have n to the 2 minus 5, which is n to the negative 3rd, which is 1 over n to the 3rd, so we need to put that guy on the bottom. And there's your answer. All right. Probably not as good an explanation on video, but I hope that helps. Good luck on the chapter review.